So how to find the domain for this function? I hope you record now. Don't be like last week. Yeah, record. Okay. How to find the domain of a rational function? We always say that the denominator cannot be 0, correct? So e to the power x plus 1 equal to cannot be equal to 0. Correct? So is there a solution for this? We know that e to the power x plus 1 is always more than 0. For all real values of x. Am I right? So that means in this case, is there a restriction for the x value? No. So therefore, the domain is equal to x. X is a member of real number. So if I make this statement, all rational function has vertical asymptote, true or false? False. Only some, not all. You see or not? Depend on the rational function that is given to you. Okay, bear that in mind. Don't think that all rational function must have a vertical asymptote. There can be cases whereby no. So there is no restriction for the value of x. So domain can be any real value. So that means it works like polynomial. Depend on. So every time when you are given a function, you have to have a look carefully. Don't generalize everything. Are you clear? Okay, good. So we have done with exponential function, natural log function, rational function. Okay, so now we want to talk about this, the last function. Okay, so if I give you fx equal to square root of 2 minus 3x. Whenever you have square root, what type of function do you call this? Anyone know? Wow, you're very good. You learned it before, is it? Radical function. Or you're going to check from YouTube already. Radical function. So it involves square root. So when anything involves square root, what must you have in mind? First idea about square root. No. If I give you a function, correct? I give you, there is no sign in front, correct? That means you have to take the positive sign. That means from here, correct? I know that my fx, the range, is always greater than or equal to 0. This is the range. I know it. This is the range. Do you know why? Because always positive, the smallest value of square root of any positive number is equal to 0. Do you know that? Okay, why you can tell me there is a plus or minus? I let you know the reason. Unless I come up with a question and ask you to solve. I say solve. X squared is equal to 5. Understand? So therefore, my x will be equal to plus or minus square root of 5. then there's a plus sign and a negative sign. But if I give you a function, I give you like that, that means I know it's always positive. You get me? Hello? Do you get me? X squared equal to 5. So there are two possible values for x. X can be negative square root of 5 or positive square root of 5. So that is called the solution. Are you clear? So this is a function. It's always take positive. Okay, so when I give you a radical function, I definitely will ask you for domain. Find the domain. So how to find the domain? For square root 0, what is the value? 0. Square root 4, what is the value? 2. You cannot say plus or minus, because I put a plus sign. I'm not solving, take notes of that, unless it's this one, that is different story. Okay, how about square root of negative 3? Who said impossible? Who said impossible? Who said impossible? Who said impossible? How should you write this? Who said undefined? You simply say, I define for you already when I teach quadratic equation. Yes. Who don't? We define it. It's square root of 3i. It is not real. It is imaginary. We define it. How can you say undefined? Don't simply use the word undefined, no. Syntax error is your calculator language. Because you didn't key in the right number. Your calculator tell you, you key in the wrong number, you expect me to calculate for you? That is called syntax error. But in maths, we don't say undefined because mathematicians have defined it as an imaginary number. Like 2 divided by 0, so far no one defined. Maybe one of the day, one of you will go and define it. How I know? I don't know. Anything can happen. Am I right? That's why maths keep improving. It makes things work. Okay. So not real. So based on this, if you want to find the domain, what must you say about whatever in the square root? Thank you. So to find the domain based on this understanding, I will say 2 minus 3x must be greater than or equal to 0. Correct? So my x must be less than or equal to 2/3. So there is no vertical asymptote because it can be equal. Correct? So therefore, the domain is equal to x. X is a member or real number, and x must be less than or equal to 2/3. Correct? So if I draw the graph, this is my 2/3. When x equal to 2/3, y is equal to 0. Am I right? So this is also called the x-intercept. Am I right? And the fx is always greater than 0. So, and the y-intercept is √2. Am I right? when x equal to 0, my f0 is equal to square root of 2 minus 0 is square root of 2. So the graph go like that. Stop here. This part, there isn't any graph because this is not part of the domain here. So there is no graph here. Are you okay? So this is called a radical function. So you see the graph is like flip over of the quadratic. Am I right? Because square root is the inverse of square. Get me? Okay, Anna? Okay, done? So now you know how to do the radical function? So all these are the concepts about radical function. Okay. So shall I give you one function and ask you to find the domain and the vertical asymptote or whatsoever? Okay, good. So now I try to mix the function up. Okay. It's very early. Okay. Given fx equal to 3x minus 1 divided by square root of 5 minus x. Okay. A. Find the domain. B. State the vertical asymptote. Yep. Find the x and y intercept. D. Describe the changes of fx as x approaches 5 from left. Okay. You take 5 minutes to try. Okay, never mind. Let's go to part A. Yeah. So we have to be very careful because the radical part is at the denominator. So we have to involve 2. Rational, the bottom cannot be 0. Radical, it must be greater than or equal to 0. So cannot be 0 and greater than or equal to 0. So combine 5 minus x must be greater than 0 because it cannot be equal to 0. Correct? So therefore, my x must be less than or equal to, you see, I write equal. Less than 5. Correct? So therefore, the domain is x x is a member of real number and x must be less than 5. So you see, less than 5. So therefore, Part B, the vertical asymptote we said the vertical asymptote always get from the domain, am I right? The vertical asymptote is x equal to 5. Okay, so let's go to part C. Okay, find the x-intercept. So you have your fx is 3x minus 1 over square root of 5 minus x, am I right? So when you want to find the x-intercept, you put the fx equal to 0, you cross multiply, means the top equal to 0. So 3x minus 1 equal to 0. So x equal to 1/3. Okay, so far I play well, huh? So therefore, the x-intercept is 1/3. Okay, so does the y-intercept exist? Yes, because x equal to 0 is part of the domain. Am I right? So the y-intercept will be f0. So it will be 3 times 0, take away 1, divide by square root of 5, take away 0. So this is negative 1 over square root of 5. Got it? So in maths, listen, in maths, the way we write the answer, make sure at the denominator there's no square root. So I should write my y-intercept as, yes, thank you. If you make the marker work, you get less mark. Why I need to write it in this form? So that the person who read this can give you the approximate value of this. So it will be 2 point something divided by 5. So it will be 0.4 something. Do you get me? So always write in this form. Okay, but for says, if you write in this form, I also will mark you right. You get me? So this is called your presentation, the way you present your answer. You make the marker work harder. The one who marked your folio can downgrade you. You understand? If you make me read, I feel very comfortable in reading that and enjoy reading it, you got higher mark. That's it. That is called writing a report. So when you write a report, whatever report, your aim is what? To make sure you don't burden the reader. You interpret everything for the reader. If you don't interpret, make the reader go and interpret what are you trying to say, then you won't get high score. You get me? Okay, now let's look at part D. What are we going to do with part D? So I know that my graph will be the x-intercept is 1/3, the y-intercept is negative. So if I draw the graph, let me draw the graph first and let you have a look at it. So it starts from 5. This is the vertical asymptote. You cannot pass through 5. Am I right? So the graph will be around here. The x-intercept is 1/3. So it will pass through this point. And the y-intercept is here. Negative square root of 5 over 5. So I want to know how the graph goes. Does it go like this? Or it go like this? So which one? 1 or 2? So I'm going to use part D to determine. You get me? I'm going to use part D. That is the purpose of part D. So I will know how to choose the graph. Yeah. So But if you look at it, definitely cannot be 2 because the y-intercept is here. So you know already. Based on this idea, you know that as x approaches 5 from the left, your fx will approach positive infinity. Am I right? So this is the one. So how are we going to argue it out? You cannot say the graph says so. You understand or not? When you say describe, you cannot say the graph says so. No, no such thing. So what do we need to do? We need to do it this way. Okay, so the part D, so I write down the function first. Fx equal to 3x minus 1 over square root of 5 minus x. Okay? Okay, so now I will say as x approaches 5 from left. So what is the x value that I will choose? So I will choose x equal to 4.999999. How many 9 you want to put up to you? Hello? Correct? So you tell me what will happen to my 3x? It will approach very near 15, correct? Okay, 15. But less than 15. Am I right? So what happened to my 3x minus 1? It will approach 14. Am I right? Then what will happen to my 5 minus x? Close to 0, but still greater than 0, correct? Agree with me? Close to 0. What is close to 0? But I put a note there. If not greater than 0, then you cannot take the square root, correct? So that means you imagine your 5 minus x will be equal to 0.0000000001. Am I right? So therefore, my square root of 5 minus x will also approach 0. Am I right? But it's not 0, huh? So therefore, my fx, which is 3x minus 1 over square root of 5 minus x will approach 14 divided by very, very, very small number will become very, very big number. Am I right? So therefore, it will approach positive infinity. You get me? So that's why the graph go in this way. You get me? Are you okay? So study of limit is very important because it gives you the idea how the graph go, how the function go as it approach something. Okay. May I ask why in this question, I didn't ask you to describe the changes of fx as x approaches 5 from the right? Why I didn't ask such a question? Yes, because the domain x must be less than 5. If I say approach from the right, this is not part of the domain where got the graph. Am I right? Okay. So the four functions that I have given you, the important thing, I told you already because they study in year 11 in Australia, but you all didn't study. So these are the things that you have to try to learn how to imagine. Can or not? Okay, so next week onward, class, next week, we really go full force into chapter 2. That will be the content of your SAT 1. And I promise you, our SAT 1 will be carried out in 3 weeks' time. Yeah. Or 4 weeks. Okay, I let you relax a bit, 4 weeks time. If you drag more on your SAT 1, then your SAT 2 will be tougher because SAT 2 is talk about the application of calculus. SAT 1 is more on theory, how to differentiate, that's it. So you want to take longer for your SAT 1 or you want to take longer for your SAT 2 in learning? Definitely 2. Because